So our next speaker is Delaney Sauer. Delaney is an underwater photographer, a dive master. She did work with birds of prey and wildlife education before coming here to the MAS MBC program. And since she's been here, she's gotten to marry those worlds of underwater photography. She became a science diver and took those skills on the road to Puerto Rico. So I'm excited for you to hear about the project that she did for her capstone. Welcome, Delaney.
I first got into photography several years ago as a way to share the things that I was seeing in and around the water with the people around me. At that point, I'd been diving for almost a decade, and I was experiencing these incredible things underwater, but I felt limited in trying to share those things with others verbally. I thought that if people could see the things that I was seeing for themselves, that they might build a stronger connection to their marine environments. I could tell you what it feels like to be underwater and suddenly be surrounded by sea lions, diving and playing, staring you right in the eyes before darting away. Or I could let you see it for yourself. I could try to explain what it feels like to be in the middle of a thick, healthy kelp forest at the perfect time of day when everything turns gold. Or I could show you. I could teach you what phytoplankton are and why they bloom and glow, but it will never have the same impact as seeing bioluminescence with your own eyes. So earlier this year, when I was brainstorming what my capstone project might entail, I thought that it would probably involve biological research and scientific diving, but I also thought that maybe this was an opportunity to tell a story through photography. And that ended up being exactly the focus of my project, just not at all in the way I expected. This is the San Juan Barrier Reef. It sits between the north coast of Puerto Rico and the rough Atlantic Ocean. This reef protects San Juan and surrounding municipalities from tropical storms, coastal erosion, and flooding. However, this reef has been severely damaged by recent hurricanes, changing ocean conditions, and it has been designated as a priority site for restoration. It's actually the first site where a FEMA-funded restoration project considers reefs to be natural infrastructure. There's a small organization in San Juan called Sail for Reefs who's been selected to lead part of this restoration project. And they will initially be focused on the restoration of elkhorn coral. Elkhorn coral is a critically endangered species which is native to the area. It creates structured habitat to support biodiversity and acts as a natural breakwater in coastal protection. There are two main things that you need to perform an elkhorn restoration like the one Sail for Reefs is planning. Firstly, you need to be able to locate live, healthy elkhorn. Elkhorn is able to reproduce through fragmentation. So you can take a piece of a healthy elkhorn, place it somewhere else, and as long as conditions support it, that coral will regrow. That being said, you also need to find appropriate outplanting habitat. Elkhorn like to live in shallow, fast-moving waters with low nutrient density, low sediment levels, and a varied bottom structure. This sounds pretty straightforward. Find elkhorn and find somewhere to put it. Exactly. However, the area that Sail for Reefs is working with for their restoration project is very large. It's over 7 square kilometers of exposed reef, which is the equivalent to over 1,300 football fields. It's simply too large an area for a small grassroots organization to effectively survey in the water. Sail for Reefs needed a way to narrow this search, which is where my capstone project begins. I had access to aerial imagery taken across 3 sites of this reef. This imagery was taken by drones flying back and forth across these sites, gathering thousands and thousands of images, 6,746 images to be exact. And some of these images were very clear. For example, in this photo, we definitely have elkhorn coral. In this image, we have another type of coral, a brain coral, and we're also seeing algal growth. However, this is a high energy area, and many of the aerial photos ended up looking like this. And even more of them looked like this. It's blurry from water movement. There's discoloration from depth. There's something mustard colored and branching here, which is characteristic of elkhorn coral, but it's also characteristic of fire coral, which we were not looking to restore, and sea fans. So there was some amount of ambiguity in these images. I went through all of these aerial images individually, categorizing and ranking them based on the presence of coral species and their percent coverage on the reef, environmental threats to future outplanting areas, such as observed algal growth, coral bleaching, and high sediment levels. And I also looked at potential hazards to humans who would be working in water in these environments during future surveys and outplanting, such as wave action and reef exposure. I organized all of these images into spreadsheets, which I was then able to export into GIS to create maps like this. These maps showed where I expected to find corals of interest and potential outplanting habitats. For example, this map shows where I anticipated there to be elkhorn coral in the Caballos site. However, as I've mentioned, many of these images contained ambiguity, and there had been bleaching events between when these images were taken and present day. So these expectations needed to be confirmed through in-water work. And luckily for me, the Atlantic Ocean starts to calm down in May outside of San Juan, and I was able to join the Sail for Reefs team for these initial surveys. I converted my GIS maps into physical field maps, which we used to plan our expeditions each day. And this was very important because I've mentioned that this is a large area, but once we were out on the reef, we really needed to know exactly where we were looking. And this aerial imaging analysis was very successful. I was able to take an image like the one on the left, where I anticipated there to be elkhorn coral, navigate to that same location in the water, and locate those same corals. This site in particular was promising in that it had previously been bleached, but was showing signs of new growth. Through the aerial imaging maps, we were able to locate healthy elkhorns, which could serve as future donor corals, donating their fragments in the restoration process. And with the expertise of the Sail for Reefs team, we were also able to locate future restoration sites. And not only that, I was able to image 11 of these future outplanting zones. I took thousands of photos of each of these sites. Photos that looked like this, focused on the reef below. And with the help of the Sandin Lab, turned those photos into three-dimensional models. These models will serve as baselines to measure future restoration progress as Sail for Reefs begins outplanting elkhorn to these areas. But these models will also be educational tools for local students and serve as a way to communicate with communities and policymakers to increase marine stewardship. Visualizations like these offer a glimpse into life below the surface that many people would otherwise never see. As reef restorations become more and more common, visualization technology can help to efficiently select and monitor sites for coral growth. Using preliminary aerial imaging analysis can direct in-water surveys of large areas to maximize limited fieldwork time and resources. And underwater large area imaging of reefs creates baseline to compare future restoration progress, climatic events, and allows communities to interact with their underwater environments in new and engaging ways. Because when it comes down to it, reef restoration is a Band-Aid on larger problems. It buys the reef more time for us to change the ways we're impacting the oceans. It's critical that people don't lose hope in what's still possible if we can adjust the ways we're interacting with the Earth. They need to see the futures of the reef that can be visualized through ever-advancing technologies. They need to see how their environments connect and feed each other, from watersheds that start on the tops of mountains and flow down through the mangroves on their way out to sea. They need to see the teams who are out on the water every day, who are devoting their lives to restoring and protecting the reefs. The same exact reefs that they grew up loving. Because future generations shouldn't have to be told stories about how the reefs used to be, how the elkhorn used to cover the seafloor, its branches twisting and overlapping, glowing gold just beneath the surface. They should get to see it for themselves. I'd like to thank my capstone committee, Antares, Isabel, and Christian. This was a very involved and multidimensional project, and I would not have been able to accomplish so much in 10 weeks without all of their guidance. And also without the guidance of the rest of the Sail for Reefs team, Kike and Sean, without Lauren, my PhD mentor, who dropped everything to come do fieldwork with me in San Juan for a week, our dive locker here at Scripps, the Sandin Lab and the Human Ecology Lab, Blue Horizons for helping make it possible for me to be in this program, and then Samantha and Hannah and all of our MAS NBC community. Thank you.
Nice job, Delaney. Do you plan to go back to Puerto Rico and San Juan and ever help finishing up this project?
I hope so. There are future phases of fieldwork that will be happening with Sail for Reefs. They'll continue surveying, and then they will start outplanting fragments from the healthy corals that we found. So hopefully there will be an opportunity for me to join that process.
Delaney, we've got a question from the YouTube. What surprised you the most about your findings or the process in this project?
I would say what surprised me the most was how often I was recognizing things that I saw in the aerial images underwater. I guess staring at thousands of photos on repeat worked. Because when I was in the water, I knew where I was a lot of the time, and I knew where to be looking. So that surprised me.
I've got a question. What happens if a fish shows up in your 3D model? Does that ever happen?
In general, it doesn't happen. The way the model processing works is it's looking for features that are the same between images. So things that move, like fish or sea fans, aren't usually recreated in those models. That being said, we had a large scorpionfish in the middle of one of our sites. And scorpionfish don't move, they're ambush predators. So it stayed there for the length of our entire dive and did get recreated into the model. All right.